of the cardiac cycle by the heart itself. And the heart we're talking about is the human heart. So we need to know what the heart has that can bring about the cardiac cycle. One, we should have to talk about the cardiac muscles. We need to talk about the conducting system of the heart that transmits impulses. Let's start with the cardiac muscles. We all know that muscles of the heart are called the cardiac muscles. The cardiac muscles are capable of contracting and relaxing rhythmically on their own without the intervention of the nervous system, and that's why we say that they are myogenic. They are myogenic. If we get muscles of the atrium, we get muscles of the ventricle. Remove them from the heart and place them in a warm oxygenated saline solution. They are capable of contracting and relaxing on their own. That's why we are saying they are capable of, in others, they are myogenic. They are capable of contracting without the intervention of the nervous system. But now the question is, do they contract at the same rate and relax at the same rate? Thus, that contraction and relaxation is inborn, it is innate. That's why we call it inherent rate. So when you look at, on average, the muscles of the atrium have an inherent rate of 60 beats per minute, and the inherent rate for muscles from the ventricle is 20 beats per minute. But now, how comes that the whole heart beats, or the heart beats 72 times per minute? What happens is what we must understand in this video. When you critically look at the atrium, there is a region of the heart that has the highest inherent rhythm, which we call the sinoatrial node. It is just situated in the wall of the right atrium, between the entries of the superior and inferior vena cava. We shall see that in a picture. I'll show you where it is located. That's where it is located. It has the highest inherent beat of 72 beats per minute. Quite unique. Quite unique. So what happens? Because it has the quickest inherent rate of about 72 beats per minute, it imposes its effect on the cardiac muscles of the atria and the ventricles. That's why we call it a pacemaker, because it imposes its effect on the rest of the muscles, and the whole heart will beat at 72 beats per minute. How does that take place? How does that take place? The sinoatrial node, or the pacemaker, generates an electrical impulse. When I talk of an impulse has two parts. One, it has a wave of depolarization that brings about contraction of cardiac muscles, and only we have a wave of repolarization which brings about relaxation of the cardiac muscles. So the sinoatrial node generates an electrical impulse that spreads on all the muscles of the atrium, starting from those of the right and later on the left atrium. However, the muscles of the ventricle are insulated from these impulses from the atrium. Why? Because we have a fibrous tissue that has a very high electrical resistance. So during that period, when impulses have been generated from the sinoatrium node, the right atrium contracts fast. Later on, the left atrium also contracts, so there is a small delay. But again, for the ventricles, it takes much longer, about 0.1 second. Now that's a tenth of a second. Why? Because the impulses don't reach the ventricles directly, but rather have to pass through what we call the atrioventricular node. However, it also has a very high electrical resistance, which must be overcome so that the impulses reach the ventricles through the bundle of His to the Purkinje fiber that reach the bottom of the heart. We go back to our question.